Geometric sequences. A geometric sequence, a sequence is a list of numbers with some pattern. Well, for geometric sequences, that pattern is multiplication. So a geometric sequence is a list in which each term, so it's a list of numbers in which each term is the previous term multiplied by some constant. Okay, and that constant that's being multiplied each time, it's called a common ratio. It's called the common ratio. So I want to write two examples of a geometric sequence, one with a positive common ratio and one with a negative common ratio. So for the first one, I'm going to do 3 as my starting term, and then I'm going to have my common ratio as positive 4. So I'm going to multiply 3 times positive 4 to get my next number, which is 12, and then 12 times positive 4 to get my next number, which is 48. What I did there, each time I multiplied by 4. So I multiplied by 4. The pattern is multiply by, what? That's not how you spell multiply. Multiply by 4 each time. Okay, and then for an example with a negative common ratio, I start with 1, the next term, and then my negative common ratio is negative 6. So I multiply 1 by negative 6 to get my next term, which is negative 6, and then I will multiply that term by negative 6 to get positive 36, and then I will multiply that term by negative 6 to get negative 216. Those are my first 4 terms in the sequence. What I did each time was I multiplied by negative 6. I multiplied by negative 6. Multiplied by negative 6. So the pattern is multiply by negative 6 each time. All right, let's derive a geometric sequence definition. So just like we did for arithmetic sequence definitions. We're going to first label these terms. So same as before, this is a sub 1, 6 is a sub 2, this is a sub 3, a sub 4, a sub 5. The subscript tells me the position in the list. I know 2 is my first term. I want to use the first term, and I want to use the common ratio to describe what the third term is. So I know a sub 3, it's 18. So a sub 3 is equal to, I have, in terms of the first term, I have 2, and then I'm multiplying each time. So I'm going to be multiplying by the common ratio. I multiplied by the common ratio, which was 3, one time, and then I multiplied by the common ratio a second time. So I multiplied by 3, and then I multiplied by 3 again. So I multiplied by a total of, so I took my first term, and then I multiplied by, I can rewrite 3 times 3 as 3 to the second power. So I could write this as 3 to the second power. For a sub 4, so my fourth term, that's 54. And if I want to write that in terms of my first term, I have 2 times, I'm going to multiply 3. I'm going to multiply 3 times. So 3 times 3 times 3. And I can rewrite this, simplify it to be a sub 4 is equal to 2 times 3 to the third power. So I have 3 to the third power. And then for my last question, it's asking the fifth term, which is 162. I want to know in terms of the first term and the common ratio, how do I write that? So 162, or a sub 5 is equal to, in terms of the first term, I have 2, and I'm multiplying 2, 1, 2, 3, 4 times to get there. So 3 times 3 times 3 times 3, and I can simplify this and write it as a sub 5 is equal to 2 times I have 3 to the 4th power. Right. All right, so I'm going to look for the pattern that I see here. And I want to write a general rule for this sequence. So I have the same list of numbers I had 3 times for these 3 situations I was looking at. So I want to write a general rule for that sequence. So now that I've answered those questions, I want to look for a general rule for this sequence, 2, 6, 18, 54, 162. I know that general rule is going to be for a sub n, where n is any number that I want it to be. So I can find the 1000th term in the sequence. I want to be able to find maybe the 100,000th term in the list. And I can do that if I come up with a formula. I look for a pattern. So, sorry, let me redo this. Now I want to take Now I want to look for the patterns that I see so I can make a general rule for this sequence for a sub n. So any n, if I want to find the 1000th term in the list, I can do that with this formula that I'm going to create based on the patterns that I see between these 3 examples. I have a sub n is going to be equal to every time I see this 2 in front. That 2 is always going to be in front. So I have 2 in front, the first term in front, and then I'm multiplying by 3 to some power. So I know that I'm multiplying the common ratio, in this case, to some power. And I want to know, what is that power? Well, I have for the 3rd term, it's 2. For the 4th term, the power is 3. And for the 5th term, the power is 4. So to find what the power is, I take n and I subtract 1. I did 3 minus 2. Sorry, nope, 3 minus 1. I did 4 minus 1. I did 5 minus 1. And that 5 came from here. That 4 came from here. And that 3 came from here. So for a sub n, I would be raising 3 to the n minus 1 power. A simpler way we could write this, it's actually not simpler, but another way we could write this, so not a simpler way, but another way I could write this is a sub n is equal to 2 times this I could write as 3 to the nth power over 3 to the 1st power, because that's what my rule for when I'm subtracting powers. I could write it like that. And then that simplifies to a sub n could be equal to, I can pull out this 3 to the 1st power. It's technically 1/3 because it's 1 over 3 to the 1st power that I'm taking out. And I could write 2 over 3, or 2 times 1/3, times 3 to the nth power. So this is another way that you can write it, and this new first term is the term before the first term. So 2/3 is the term before the first term. So if I were to divide by 3, I would get 2 over 3 is my a sub 0. All right, let's write an explicit definition for any scenario with any list, and a recursive definition. So for the explicit definition, we have 2 things we can write. A sub n is equal to, so explicit again is in terms of the first term. So it's based on first term. And then recursive definition is based on previous term. So a sub n for explicit definition, a sub n is equal to a sub 1 times, that's the first term, times r, which is what we're going to use to represent the common ratio, raised to the n minus 1 power. I almost don't want to talk about the other. Well, or you can write a sub n is equal to a sub 0 times r to the nth power, where a sub 0 is term before first term, and R again is the common ratio. All right, so those are the two that you can use. Actually, what I like to use best is this one for when I'm talking about geometric sequences. I like to use that one. It's usually easier to use. All right, for the recursive definition, I have a sub n is equal to the previous term. So the previous term I would write as a sub n minus 1, and then that I'm just multiplying by my common ratio. So this is the previous term, or preceding term. All right, and then I want to find the rule with these examples. So I have example 4, 12, 36. I am seeing what I'm multiplying by each time. I'm multiplying 3, multiplying 3. So the common ratio is 3. The first term is 4, and then my rule would be 4 times, I have 3 raised to the n minus 1 power. So 3 is the common ratio, and that's my answer. And then for the next example, to find the rule, I would find what am I multiplying by each time. This is negative 1/2. Right? Negative 1/2 each time that I'm multiplying by. Put that in parentheses. Times negative 1/2. So it's negative 1/2 is the common ratio. My first term was 8, so my rule is 8 times negative 1/2 raised to the n minus 1 power. Negative 1/2. Okay? All right. Now I want to find the rule and then use it. So I have a list 2, negative 6, 18. For that rule, I need to, the important thing is it's a geometric sequence. I want to see what am I multiplying by each time, and I'm multiplying by negative 3 each time. So I'm going to use a sub n is equal to my first term, which is 2, times, and then I do negative 3 raised to the n minus 1 power. And that's going to be my rule. I'm going to use this one because I like it better than the other one. You could use the other one if you like that one better. And then I'm going to do for the 18th term, so I'm going to do a sub 18 for the 18th term, which means everywhere I see an n, I'm plugging in 18. So I do negative 3 to the 18 minus 1 power. Or sorry, yeah. So negative 3 to the 17th power times 2. And you have to do this in your calculator. This is why you need a calculator for this class. Negative 3 to the 17th power times 2 is going to give me a really big number, 258,280,326. And that is my 18th term. That's how big it is. Which term number is negative 4,374? In this case, I'm going to use my rule. So I have a sub n is equal to 2 times negative 3 to the n minus 1 power. And I know what my a sub n is. My a sub n, I was given my output. I was given what the actual term is, and I want to find what position it's in. So I want to find the n. A sub n is negative 4,374. So that is equal to 2 times negative 3 to the n minus 1 power. Now, what I want to do first is I want to get rid of this 2 in front. I want to have a base raised to a power. So I'm going to divide by 2 on both sides. I'm going to get negative 3 raised to the n minus 1 power is equal to negative 2,187. So negative 2,187. From there, I want to rewrite negative 2,187 in terms of negative 3 to some power. Then you can play with it in your calculator. Its exponent isn't going to be that big. It's going to be somewhere in between 1 and 10 because otherwise it'd be a super massive number like this one. So I want to try a bunch of my calculator, and I'm going to find that negative 2,187 is negative 3 raised to the 7th power. And I have negative 3 raised to the 7th power is equal to negative 3 to the n minus 1 power, which tells me that 7 is equal to n minus 1. So I write that on the side. 7 is equal to n minus 1. Add 1 on both sides. And I find that n is equal to 8. So it's the 8th term. Okay. All right. Let's try the next example. So 18, 6, 2. I'm multiplying by 1/3 each time. And so my rule is a sub n is equal to my first term, which is 2 times, no, I'm sorry, not 2, what the heck, 18 times, and then I have 1/3 raised to the n minus 1 power. And that's my rule, and I'm going to use it to find the 8th term, so I'm going to do a sub 8. And I'm plugging in everywhere I see an n, I'm plugging in 8. So I have 8 minus 1. And then from there, I'm going to have a sub 8 is equal to 18 times 1/3 to the 7th power. And I do this in my calculator. I'm going to get a sub 8 is equal to 18 over 1 times 1 over 3 to the 7th power is, we just did that, 2,187. And then this simplifies to be a sub 8 is equal to 2 over 243 when you simplify. And that's my answer. And then I want to know which term is number 2, is the number 2 over 27. So this is my a sub n that was given to me. I have the formula a sub n is equal to 18 times 1/3 to the n minus 1 power. I am plugging in, this is 2 over 27. And then I want to solve for what n is. So first thing I'm going to do is I'm going to divide by 18 on both sides, or multiply by 1 over 18. Because I have a fraction on the other side. So it's the same as dividing by 18. I'm going to get on the left-hand side then 2 over 486. And that's equal to 1/3 raised to the n minus 1 power. And then I'm going to simplify this to be 1 over 243 is equal to 1/3 to the n minus 1 power. And then really I just need to know 3 to what power is 243. And that's, if I play in my calculator, it's 3 to the 5th power. So I really have 1/3 to the 5th power. If I rewrite that left-hand side, is equal to 1/3 to the n minus 1 power. So 5 is equal to n minus 1. So n is equal to 6. So it's in the 6th term in the sequence, and I want you to try this example on your own. All right, for geometric mean, we have, for the geometric mean, to find we do the nth degree of x sub 1 times x sub 2 times x sub 3 times all the way to x sub n. So if I wanted to find the geometric mean, for the first example, I'm just going to figure it out based on logic, what the number in between is going to be, by the fact that I know that I have to multiply by r to get that term in between, and then I have to multiply that term by r to get 72. So I'm going to write an equation to solve. I have 18 times r again, is equal to 72, or I can write 18 times r squared is equal to 72. I had to multiply r 2 times by 18 to get 72. And then I'm going to divide both sides by 18, and I'm going to see that I have r squared is equal to 4, and then I take the square root of both sides. And I find when I decide to take the square root, I need to include the positive and the negative. So I have r is equal to plus or minus, that's not my answer, but r is equal to plus or minus 2. So I could either have, I multiply 18 by 2 to get 36, or I multiply it by -2 to get -36. So I have both positive and -36 are my possibilities for what could be in between 18 and 72. For the next example, I'm going to use this geometric mean. So I have these two numbers and I want the number in between, which means I'm going to be taking the square root, since I'm taking the second root of multiplying these two numbers together. So I'm multiplying 12 times 4,374, and I don't want that comma there. And then I'm going to put that in my calculator and see what I get. And when I do that, I'm going to get plus or minus. You have to always include the plus or minus if you're taking the square root, of 229.1 about. So I could put here positive 229.1 or negative 229.1. And then for the last example here, I have a sub n minus 1. I have a sub n plus 1, and I want to find a sub n. That's the number in between. So I have this is 2 over 5. This one on the right is 8 over 45, and I want to find this one here. I'm going to use the geometric mean again, so I'm going to do the square root, because I have two terms multiplied together, of 2 over 5 times 8 over 45. That's the square root of 16 over 225. Which is plus or minus, if I want to leave it as a fraction, that's 4 over the square root of 25 is 15. So I could put plus or minus 4 over 15. For this last part, I want to be able to use the recursive definition. So I have the 15th term, I want to find it, so I don't know what it is. So I'm going to write an equation with a sub 15, and I've been given the 16th term and the common ratio. So I know the way that I can use those two things in an equation. I have a sub 15 times 6, that's my common ratio, is going to be equal to a sub 16, or 9. I'm going to find what a sub 15 is, I'm going to divide both sides by 6, and that's going to tell me a sub 15 is equal to 9 over 6, or I can simplify that to be 3 over 2. And that's my answer. For finding the 42nd term, if I've been given the 40th term, I have a sub 40 is 10. A sub 41, I'm going to multiply by -5, and that's going to give me -50. And then to get a sub 42, I will multiply that by -5, and that would give me 250. So a sub 42 is equal to 250. So the 42nd term is 250. All right, for this last one here, I want to find the 14th term if a sub 4 is equal to 32 and r is equal to 2. I want eventually the rule, the general rule, so a sub n, which is equal to a sub 1 times r to the n minus 1 power. I've been given one example, so a pair of the number and so the term and the position. So I can plug in, I know a sub 4 is actually 32. So I'm going to do a sub 4 is 32. And that's equal to a sub 1 times, I'm going to replace what I know, and I know r is 2, so I'm going to put 2 here. 2 to the n minus 1 power, and n in this case is 4. So it's a 4 minus 1. I'm going to simplify this now. I have 32 is equal to a sub 1 times 2 to the 3rd power. And then I'm going to solve for a sub 1. So I have 2 to the 3rd power is 8. It's actually 8 times a sub 1 is equal to 32, which means a sub 1 is equal to 4. And I'm going to use that. So now I have my final, I was only missing a sub 1 before. I have my final rule, my general rule is 4 times 2 to the n minus 1 power, and I'm going to plug in, I want the 14th term, so I'm doing a sub 14 is equal to 4 times 2 to the 14 minus 1 power, and then when I simplify all of this, I'm going to end up with 2 to the 13th power times 4, which gives me a total of 32,768. That's going to be the 14th term.